Hello viewers, I am Kausalya. Today we are going to solve problem number 3 part 2 under the topic Bode plot. The problem is plot the Bode diagram for the following transfer function and obtain the gain and phase crossover frequencies. And this is the given problem. Now we are going to find the phase values for the given expression. So this is the given problem. From the given problem, we have substituted the value of S as j omega here. Right. And the next step is we are going to find the expression for calculating the phase angle. So here you see omega lies in the denominator part and omega always contributes an angle of 90 degree. I am moving this omega to the numerator part. So here I have included minus 90. Right. And the next is we are having 1 plus 0.4 j omega. So how to calculate the angle for this expression? Again the formula is it is given by tan inverse of imaginary coefficient divided by real term. Okay. So here in this case what is the imaginary coefficient? It is 0.4 omega. What is the real term? The real term is 1 here. So once you substitute here, you are getting the value as tan inverse of 0.4 omega. Again, this is a denominator term. I am moving this to the numerator part. So here I am having minus tan inverse of 0.4 omega. Right, and the next step is here again when you use this formula, tan inverse of imaginary coefficient is 0.1 omega and the real term is 1. So again tan inverse of 0.1 omega, when I move this to the numerator, I am including a minus here, right? So 10 is a constant, so it won't have any angle, so we are not considering the 10 here. Here we had considered only the denominator terms, right? Hope you people are clear with this. Now we are going to form our second table. So this is our second table. So here in this case we have to include all the 4 frequency values, that is omega L, omega C1, omega C2, omega H. Okay, these 4 frequencies must be included in the table. Apart from that, we can include the middle values or in between values, right? So here these are all the list of frequencies I have taken for consideration. You see 0.1, 1, 2.5, 4, 10 and 20, right? Now we are going to calculate the phase angle for each and every values of frequencies. So here I am having 2 terms, right? So here I am writing tan inverse of 0.4 omega and here 0.1 omega, and finally the value of phase angle is calculated. So here these are the things which are done by using a calculator. So you can done by yourself. It is very easy. And while finalizing the phase angle, you see whenever I am having degrees in points, that is 92.8, you can simplify it as either 92 or 93. Okay, this won't make much bigger difference. Similarly, you see 117.5 here is resolved to 118 and here 149 as 150. So 169.79, so I am writing it as 170. Similarly, 210.96 as 210 and 236.3 is resolved into minus 236. Right, you can round off to the nearest value. No need, you should always do like this only. You see the first term here minus 92.86 can be rounded off to 93 also. Okay, that won't make any difference in your final answer, right? Now we are going to plot both the magnitude as well as phase plot in a semilog sheet. This is our magnitude table. Now we are going to mark these points on a semilog sheet. So as usual, in a semilog sheet, the x-axis always corresponds to the corner frequencies. You see, x-axis always corresponds to corner frequencies and y-axis corresponds to the magnitude. Right, depending upon the values of magnitude, we can take the scale accordingly. Okay, no need, we should always take the scale like this. You can take as per your wish. Right, so here in x-axis, the corner frequencies are marked and in y-axis, the values of magnitudes are marked. Now we are going to plot each and every point. So the first point is, you see, the value is 0.1, the magnitude is 40. So here, when you look at this semilog sheet, wait, let me zoom in. zoom out. The first value is omega is 0.1 and magnitude is 40. You see, here lies our 0.1 and here is our 40. So this is our first point, right? And the next one is omega is 2.5 and the magnitude is 12. So this is 1 and this is 10. So between 1 and 10 lies 2.5, right? So when you look here, so this is my 2 and this is my 3. So between 2 and 3 lies the 2.5. So here lies the 2.5. So for 2.5 the magnitude is 12 dB. You see, this is 2.5 and this is our 10. So here comes our 12, right? So this is our second point. And the third one is omega is 10 and the magnitude is minus 12. So here I am having 10 and the magnitude is minus 12. So when you move gradually, you see, here is minus 10, right? So this will be our minus 12. So when you mark the point, this is our third point, right? And finally the last one is 50 at minus 54. So between 10 and 100 lies 50, right? The magnitude value is minus 54. So you see, this is my 50, right? So the magnitude is minus 54. So this is my 50 and here 52 and this is my 54, right? So finally we had drawn our magnitude plot. Hope you people are clear with this. Now we are going to join these lines using a scale. Even you can name these points as I already said. Okay, let it be A, let this be B, let this be C and let this be D, right? So first join A and B. And next B and C. And finally C and D. Right? Our magnitude plot gets over here. The next step is we have to write the slope. So for writing the slope, again we have to go back to the table. So what is the value of the slope initially? It is minus 20. So here between A and B, you have to write the value of slope as minus 20 decibels per decade, right? Then what is the change of slope here? During the next step, the change of slope is minus 40. So between B and C, you have to write it as minus 40 decibels per decade. And finally, the change of slope between this point and the next corner frequency is minus 60 here. So here between C and D, you have to write minus 60 decibels per decade, right? So when you look at the slope, it is very clear that the slope gets very much narrowed when the value of this decibel get increased. You see, for minus 20 it is like this. But when it goes to minus 40, you see, this is, when you extend this minus 20 line, it will be going like this, right? But it gets narrow here, it is bending down. So here comes minus 40. And here the next is minus 60, right? It gets again narrower than minus 40. You see, when you extend this minus 40, my line will be going like this, right? But you see, it is getting narrowed down, right? So we can check whether the slope is correct or not depending upon these values, right? Then the next step is we are going to plot the phase plot. So this is the table of our phase plot, and now we are going to mark it on a semi-log sheet. So you see, we have to select the values, that is phase angles, depending upon the values we got from our table 2. So accordingly, you see, I had started from minus 60 and I had drawn till minus 240. Okay, these are the range of values which we need. Then the next thing is we have to plot as usual. You see, The first value is 0.1 and the value of angle is minus 92. So we'll mark that first. You see, this is our 0.1 and the value of angle is minus 92. So here I am having 80, right? Then the next line will be 84, 88. Then here comes our 92. That is the third line from 80 will give you 92. So here from this point you have to mark, okay? You just go by this line. When you go straightly, okay, it hits over here. So for 0.1 the value of this angle is minus 92. I had marked here, right? The next one is for 1 the angle is minus 118. So 118, where it lies our 118? Between 100 and 120 lies our 118. Again you have to move gradually. Okay, you have to move gradually, and finally for the value of 1 you have to mark the respective points, right? Similarly you have to mark for each and every frequencies, and finally we are going to draw our phase plot now. So finally we have drawn our phase plot here. After plotting the points you have to join the dots by freehand, okay? No need to use scale here. So this is our phase plot, right? So the first part of the problem is over here, that is we have drawn the Bode plot, right? Magnitude plot is drawn and this phase plot is drawn. The second thing is they are asking us to find the phase crossover frequency and gain crossover frequency. So what is a phase crossover frequency is the frequency at which your magnitude plot crosses the 0 decibel line, right? That gives you the gain crossover frequency. Again, the phase angle, the point, the frequency at which your phase plot crosses minus 180 degree line gives you the phase crossover frequency, right? When you deal with magnitude, you have to tell it as gain crossover. When you deal with phase, you have to tell it as phase crossover, right? So here you see, this is our 0 dB line. You should always highlight this 0 dB line and minus 180 degree line for each and every problem, right? So this is the point where our phase plot crosses our 0 dB line, right? So at this point we have to check what is the frequency. So you see at this point exactly the value is 5. So this is my 0.1 and this is my 0.10. So here this point is 5. So we can say the value of gain crossover frequency is 5, right? Similarly, when you look at this phase plot, again this phase plot crosses this minus 180 degree line at some point, right? Just highlight that point again. Okay, this is the point where our phase plot crosses minus 180 degree line. Now correspondingly check what is the value of frequency. So what is the value of frequency over here? You see at this point again the value of frequency is found to be 5 radians per second. So here both the frequency values are same, that is gain crossover frequency and phase crossover frequency both have the same value. The value is 5 radians per second, right? So finally here we are writing the value of phase crossover is equal to gain crossover and the value of the frequency is 5 radians per second, right? If you want you can just draw a line and show, or else no need. So here comes our conclusion, and finally we are writing it in the result. So the value of gain crossover frequency is 5 radians per second, and similarly for phase crossover frequency also 5 radians per second. No need that both the frequencies should always have the same value, right? They may differ. So hope you people understand the problem. If you have any doubt, feel free to ask me in the comment section. Thank you.